Okay, so this unit has to do with the gradient of a straight line. So let's say we have a Cartesian plane and we have a straight line that originates from the origin here. So that's x, that's y. So and an angle theta. So let's say we go back to the original unit circle that we talked about previously. So what I want you to focus on is this bit over here. You can see that just this bit over here. Tangent theta is equivalent to y over x equals to sine theta over cos theta. So this is the bit that's really important in this unit. So let's see how they are related. Going back to this one, if we are talking about a gradient of a straight line, a gradient is always represented as an m, and we know that the gradient is always the rise over run. So in this case, it is the rise, which is the y, over the run, which is the x. So it's kind of like y over x as mentioned in just now. And we know that y over x, let's just check again. Y over x is sine theta over cos theta. So let's just copy this here, equals to sine theta over cos theta. So now that we know this, we know that sine theta over cos theta is also tangent theta. So the gradient in this case is tangent theta. So if, that's another important concept that you need to know, which is the equation of the straight line. Okay, as we have learned previously, the equation of the straight line is y equals to mx plus c. What do I mean by that? So, x and y are obviously a point on the line, so that's just the coordinate. The m, as we have learned just now, is the gradient. And what about c? The c is a y-intercept. It's when the line crosses the y-axis. Where does it cross? So, and we also learned previously that when your gradient is positive, so let's say when my gradient is positive, so it kinds of like go up. It's a line that goes up this way. So if you look from left to right, this is kind of like going up. So this is when the gradient is positive. So what about when the gradient is negative? When the gradient is negative, so from left to right, it's kind of going down. Okay, so this is when gradient is negative. What about when it's flat like this? This will be like, that's sort of like when the gradient is 0. Is this okay? So where is the y-intercept in this case? Y-intercept, this is my x and this is my y. So my y-intercept will be when the line crosses the y-axis. So this is my y-intercept. This is also my y-intercept. And this is also my y-intercept. So this is also a very important concept to understand when you're doing this. So let's talk a little bit more about this. So we'll talk about parallel lines. So for this gradient that is positive, if there is another line that is parallel to this line, we will say that these two lines will have the same value for the gradient. So if we have another parallel line that goes here, this will be also a line with a negative gradient and they will have the same negative value. Does that make sense? Okay, let's solve a question here. So for example, I have a graph where this is x and this is y. And let's say I have a y-intercept of 1 and a angle of pi over 6. The first question, I'll just separate this out. The first question is find the gradient of the line. So A, find the gradient of the line. I'll just say find the gradient. Okay, so how do you find the gradient? As we have learned just now, the gradient is the m, which is the tangent theta. So the gradient is the m, which is the tangent theta. But in this case, the tangent theta is a tangent pi over 6. So what's a tangent pi over 6? We need to refer back to this table here. A tangent pi over 6 has a value of 1 over square root 3. So let's just copy this down. 1 over square root 3. Do you think this value is correct? Yes, it is. Why is it correct? It's because from left to right, you can see that the line is going upwards and therefore this is a positive. So we'll just leave this value here. We don't have to write a positive value. The next question is find the equation of the line. Find the equation of the line. So if we want to find the equation of the line, we know that the equation of the line is y equals to mx plus c. So y equals to mx plus c. How do we put it correctly? Because in every time we write an equation of a straight line, we just need the x and the y, not the m and the c. The m and the c needs to kind of have their own sort of values. So m will be, in this case, it's 1 over square root 3. X, we just copy it down. Plus, what's the value of my y-intercept here? So, green crayon. The value of my y-intercept is 1. So, if I want to write the equation of a straight line, the equation of the straight line is y equals to 1 over square root 3x plus 1. Let's say we have a graph that is like this and we need to kind of find the gradient of the line. So this is obviously x and y. So this looks really different from what we have done just now because this is kind of like next to the x-axis and this is, well, sort of like next to the x-axis as well. So you can actually find the gradient is m, which is equivalent to tangent pi over 6. So tangent pi over 6, how do we find the value? We use the table. Tangent pi over 6 is actually a 1 over square root 3. So equal to 1 over square root 3. And then we have to check the signs. Is this correct? We learned before that this is sort of a line that's going down. So for a line that's going down, the gradient needs to be negative. So we need to write a negative here, and that's done. So what if we have a question that is slightly different? Like, for example, we have a question that's going this way, and there is a value here, and that's 2 pi over 3. How do we solve a question like that? If this looks really confusing and this doesn't even look like an acute angle, do not worry. You just have to kind of create another parallel line that looks more familiar. What do I mean by that? You need to create a parallel line. Maybe it goes through the origin. Then it looks more familiar. Does that make sense? So copying this down as a corresponding angle, we have 2 pi over 3 here, but it's only the acute angle that we want. To get the acute angle, which is this cute little one here, we need to take away the pi over 2. Does that make sense? So let's go back to the calculator. We need to find the acute angle. So that's 2 pi over 3, take pi over 2 equal to, that's 1 over 6 pi, or it's pi over 6, it's the same. So taking this little one here, so m equals to tangent pi over 6. What's pi over 6? We need to go back to this table. Tangent pi over 6 is 1 over square root 3. So 1 over square root 3. And we can see that this is sort of like a line that's going upwards. So a line that's going upwards has a gradient of positive. So positive gradient, this will be it. So hopefully you understand and that you can do well in the test. So all the best. Bye-bye.